A very good afternoon to all the dear students. So I welcome you all to this session of DA, and we will be doing quick sort in this session. So what is quick sort? It is another algorithm which is based on divide and conquer approach. So I will write DAC, that is divide and conquer approach. Here, suppose we are having an array. Suppose this is an array 56014. I'll take one more element, that is 2. Okay. So here I will pick one element. So here I will pick one element, any element. Suppose I'm picking this last element. So this last element is called pivot element. The element which I am going to choose is called pivot element. The pivot element could be the beginning number, it could be the last number, or it could be the middle. Fine. And after dividing this problem into sub problem, what would be the result? That this element will get its final position where the left element of it will be smaller than this number and right to it is greater than this. Means the list will be settled in such a way that the element towards the right of 2 will be greater than 2, and elements towards the left of 2 will be smaller than 2. But they may be sorted, they may not be sorted. They may be sorted, they may not be sorted. If they are not sorted, then we are going to sort it. Okay. And we will apply this technique recursively. That is, divide and conquer says divide the problem, bigger problem into smaller sub problems. Then solve the sub problems individually, get the solution for the sub problems individually, combine all those individual solutions to get the final solution. So we will make a recursive function in order to find the partition. Then we will apply the quick sort on both the left side and the right hand side. So this is left hand side sublist, and this is your right hand side sublist. That is, pivot element has got its position fixed. Supposing how many elements are there? 1, 2, 3, 4, 5, and 6. Now 3 position has been fixed for pivot element, that is the 2. After performing the partitioning algorithm, there is one partition algorithm which is followed in quick sort. After applying the partition, your pivot element will be getting its fixed position, that is where it is supposed to be, where it should be rather. That position will be there and it will be placed on that particular position. And towards the left hand side, the smaller elements would be placed, and towards the right hand side, bigger elements would be placed or larger elements would be placed. So this will be a partition where you will get the final position for your pivot element. And then you will perform the same operation on left hand side sublist and on the right hand side sublist. So this will follow the recursive algorithm approach. So this will follow the recursive algorithm approach. Now, how to choose this pivot element? What could be this pivot element? First, it could be the first number from the array. It could be the first number from the array. It could be the last number from the array. Number 3, it could be the middle element. Or it could be the random number. Means if I talk about this particular array, the pivot element could be 5, it could be 2, or it could be either 1, or any random element, or it could be 4. Random element means 4, 2 is the last element, middle element is 1, or you may say 6 by 2 is 3, the third element, that is 0. You may take 0 as a middle element as pivot, or first element, that is 5 as a pivot element. Okay, so first number from the array it could be there, last number from the array it could be there, middle number from the array it could be there, or random number from the array could be there. But desirable if we don't have the option to select first or last, we always select the middle element. Preferable is middle element. People prefer, uh, to choose the middle element because the list will be divided equally into two sublists. Whenever we choose the middle element as the pivot element, then it is likely that the list would be divided into two equal halves. Two equal halves. That's why it is preferred, because time complexity will definitely decrease. Here you can say there are two elements on the left side and three elements towards the right side. What does that mean? Two elements towards the left side and three elements towards the right side. That means lists are not divided equally. Here the lists are divided equally. Fine. So there is a probability whenever you take the middle element as a pivot element, then the list will be of two equal halves and time complexity will decrease as compared to choosing the first element or last element. Okay. So we will have the look at the partition algorithm now. I will take an example to explain you how this partition algorithm works recursively. So this is your partition algorithm. Partition will be performed on the array of elements beginning from P till the last element. Right? So A is the array of elements. P is the beginning index. And R is the last index of the array. I'll give you an example, then I'll show you how this partition algorithm works. Initially store the AR, that is last index or last element of the given array, into the X. Last element into the X. Then we will run the loop. You will write I is equal to P minus 1. This is one counter variable. For J is equal to P to R minus 1. Since we have stored R in X, we have stored A of R in X. So we will move the loop from for J is equal to P to R minus 1. For this, if A of J is less than equal to X, then what we have to do? I plus plus increment I by 1 and exchange A of I with A of J. Then after closing this loop, A of I plus 1 is equal to A of R. So you are going to exchange A of I plus 1 with A of R. Then return I plus 1. This is your position where the pivot element would be stored. Now let's do the example of this. See, I explained the algo once again. Partition algorithm first will be called. Before discussing the quicksort algorithm, we have to discuss the partition algorithm. Partition would be done on the array of elements. Starting index would be P and ending index would be R. Now X is equal to A of R, that is last element would be stored into X, or you may say it as key. X is nothing but the key. Then I is equal to P minus 1, starting index minus 1. If my I is starting, suppose my J is starting from 1, then my I would be 0. So for J is equal to P to R minus 1, P is the beginning index to R minus 1 because we have stored the last element into the key. Now entering into this condition, what we have to check, if A of I, if A of J is less than equal to X, A of J is less than equal to X, then increment I, then exchange AI with AJ. After this, J will be performed from the starting index till the last index, or last minus 1 index. Then we have to exchange A of I plus 1 with AR. So let's take an example. From this, first of all, let us get so the elements are 9, 6, 5, 0, 8, 2, 4, 7. So today we'll be taking the last element as the pivot element. So I am selecting this element as the pivot element or key. So what you will write here? Indexes begin from 1, 2, 3, 4, 5, 6, 7, and 8. So step 1, according to algo, we will run x is equal to AR. So put x is equal to AR. AR is A of 8, which is equal to 7. Then I is equal to P minus 1. P is my beginning index. It is starting from 1. So I is equal to P minus 1, which is equal to 0. So value of I is equal to 0, x is equal to 7. And for j is equal to P to R minus 1, that means we have to run the loop from 1 to 7. R minus 1 is 7 and starting index is 1. So I will move from 1 to 7. So j will be moving from 1 to 7. That means after 7 times going from this statements, we will and finally close this loop. Now for j is equal to 1 and I is equal to 0 and x is equal to 7. I'll write here j is equal to 1, I is equal to 0, then x is equal to 7. Now what you have to check? If a of j is less than equal to x, a of j is starting from 1. So a of 1 is less than equal to 7, that is my x. A of 1 is 9. 9 is not less than equal to 7. Condition becomes false. Condition becomes false. So no action has to be take place. No swapping has to be done. No swapping has to be done. Okay, step 2. Since j has to increment, I will remain same, x will remain same. So I will be 0. J is moving from 1 to 7. So this time j would be equal to 2 and x would be 7. Now check if a of j is less than equal to x. A of 2 is less than equal to 7. A of 2 is 6. 6 is less than equal to 7. Condition is true. Now what we have to do? Increment I, then exchange. Increment I, INC I by 1. Now I has become 1, which implies I is equal to 1. Exchange A of I with A of j. Exchange A of 1 with A of 2 because j's value is 2. So swap A1 and A2. So the output for the first step would be 9 and 6 will be swapped. So 6, 9, 5, 0, 8, 2, 4, 7. And 7 is again my pivot element. And the indexes are varying from 1, 2, 3, 4, 5, 6, 7, and 8. So this is my output of step 1. If it is not visible, I'll write here only. 6, 9, step 1. This is my output. By exchanging 2 with 1, you will get 6, 9, 5, 0, 8, 2, 4, 7. Okay. Now step number 3. For I is equal to 1, for I is equal to 1, j is equal to 3, and x is equal to 7. You will check if a of j is less than equal to x. So a of 3 is, that is 5. 5 is less than 7. Condition true. Now increment I. So I will be incremented by 1. So I will become 2. Increment I. So I will become 2. And then exchange A of I with A of j, that is A of 2 with A of 3. That means after exchanging, what would be the final array? 6, 5, because A2 and A3 are exchanged. 6, 5, 9, 0, 8, 2, 4, and 7. 1, 2, 3, 4, 5, 6, and 7, and 8. So this will be the final output for step number 3. See, I is equal to 1. J is equal to 3, X is equal to 7. So at 3 number, you have the element 7, and here 5 is less than equal to 7. So condition is true. Then increment I will become 2 and exchange AI with AJ. So we have exchanged 2 and 3. So 6, 5, 9, 0, 8, 2, 4, 7 will be the output of the step number 3. Okay, now step 4. Here J will become 4. I pick this value, I is equal to 2 and X is equal to 7. Now again check if A of J is less than equal to X. Now at the index 4 we have 0. So 0 is less than 7. Condition is true because A of J is 0. A of 4 is 0. So 4 is less than equal to 7. That is 0 is less than equal to 7. Condition is true. Now increment I by 1 and you will get I is equal to 3 and J is equal to 4. Now exchange A of I, that is 3, with A of J, that is 4. That is A3 and A4 will be exchanged. So what will be the output? 6, 5, 0, 9, 8, 2, 4, 7. And the indexes are varying from 1 to 8. So 6, 5, 0, 9, 8, 2, 4, 7. So this will be the output for the step number 4. This will be the output for the step number 4. Okay, so you will get this 8 no 4 7. I'll write upwards. This is how it is doing. Now next step number 5. So X is equal to 7. Now I is equal to 3 and J is equal to 5. A of J, if A of J is less than equal to X, that is 8, because A of 5 is 8. So 8 is less than equal to 7, no, condition false. So no step will take place. We have to increment J, simply increment J. So X is equal to 7. So this was my step number 5. Now step number 6. X is equal to 7, I is equal to 3, and J is equal to 6. Now, so 6, if A of J, that is A of 6, is smaller than X, that is 7. So A of 6 is 2, 2 is less than 7, that is true. Now increment I will be 4, because we have incremented increment I, it becomes 4. Now exchange A of 4 with A of 6. Exchange A of 4 with A of 6. So let's exchange 4 and 6. So this will be swapped here. Okay, so 2 will come here and 9 will go there. Okay, now next step, I will take here only. Now I is equal to 4, j is equal to 6, and x is equal to 7. Now a of 6 is 9. 9 is less than 7. A of 6. Sorry, a of 7 we have to take. Sorry. Here we have to take a of 7. J would be 7 here. So a of 7 is less than, a of 7 is 4. So 4 is less than 7. Condition is true. So what we are supposed to do? Increment I would be 5. Then I would be 5. Then exchange A5 with A7. Exchange A5 with A7. So after exchanging, you will get A5 with A7. So 4 will be here and 8 will be here. Okay. Now we will not go to 8th position because we have to stop the loop here. Since this condition is satisfied P to R minus 1 and we have applied all the condition. After the loop is over, exchange A of I plus 1 with A of R. A of I plus 1 is increment I, which is equal to 6. So A of 6 with A of 8 because my R is at the 8th position. A of R last index is at 8th position. So swap these two numbers. So you will be swapping and final output will be like this. 6, 5, 0, 2, 4. Now 7, 8 and 9. Now please note it carefully. 1, 2, 3, 4, 5, 6, 7, 8. Since this is my pivot element, that is 7, and the elements towards the left of this pivot element are smaller than 7, whereas the element after the 7 are greater than it. That means left sublist will contain the smaller elements and right side will contain the larger element. That means pivot position is fixed, that is 6. So this is going to return I plus 1, that means partition will occur around 6th position because the element before the 6th position are the smaller ones and elements after the 6th position are the bigger ones or the larger ones. So this will return me the partition, that is, or Q you can say, that is the position of the pivot. It will return me the position of the pivot element. It will return me the position of the pivot element. Now I will write the algorithm for the quick sort. So quick sort will have the array of elements. P is the beginning index and R is the last index. Okay. Now we will write this algorithm will execute only if P is less than R. Then you will call partition A comma P comma R. So this will be equal to Q. That is the element position which was returned to us. See, quick sort A comma P comma R. If P is less than R, because your first beginning index is less than the highest index or the last index, there is 1 is less than 8, only then this algo will be calling. Now Q is equal to partition A comma P comma R. It will make a call to the previous algorithm which we have done. That is array, then beginning index, then last index. It will return you the partition. That is where the pivot element is fixed. In earlier case, it was 6 because at 6th position, the 7 number was fixed. Now quick sort A comma P comma Q minus 1. That means your list will have two quick sorts. Now one quick sort will be performed from 1 to 5 because R would be Q minus 1. Before partition, one sublist would be there, and after partition, next sublist would be there. So this is Q minus 1, and this is Q plus 1. Quick sort A on array, that is Q plus 1. Your beginning index will be now 7 and ending index would be 8. So that means if I call quick sort, I will write it like this: US 1 comma 8, since my index are starting from 1 and ending at 8. So one element is fixed. So there will be first partition call. Partition will be giving me A comma 1, that is, sorry, right, 1 comma 8. Partition of 1 comma 8 has returned me Q, which is equal to 6, because at 6 number position, I'll write in a clean manner. P 1 comma 8, 1 comma 8 has given you Q, that is 6 number, where my 7 is fixed. Okay. Now quick sort, P is 1 and Q is equal to 6. So 6 minus 1 is 5. So that means first sublist, that is 1 comma 5. We have to apply the quick sort again. We have to apply the quick sort again. Next. Then quick sort will applied on Q plus 1, that is 6 plus 1 is 7, 7 comma 8. Okay. Now this will again give you the partition. You will call partition 1 comma 5. So let us do the quick sorting or partitioning algorithm on 1 comma 5. Again that things will be performed and we will see how these elements would be arranged. So let's do it. So this is 6, 5, 0, 2, 4. Very small list I am taking. 1 comma 5. So J will move from 1 to 4. And this is my X is equal to 5. Sorry, X5. That is 4 is my key. X is equal to A of 5. That is equal to 4. And I will be equal to 0 since I is equal to P minus 1. P is starting from 1. So I will be equal to 0. Now what happens? Step number 1. Whether 6 is smaller than 4? No. 6 is not smaller than 4. No swapping. No action has to be taken. Then increment J by 1. So J will become 2. X is equal to 4. And I is equal to 0. At J is equal to 2, we have 5. 5 is less than 4. Condition false. So no swapping or no action has to be taken place. No action will take place. Okay. So next 0. One, two, three, 4, and this is like this. Okay, 0 is less than key, that is 4, that is J3. J is equal to 3 and A of I is equal to 0. So 0 is less than 4. Condition is true because your J3 is, if A of J, that is if A of 3 is less than my key, it is true. Now increment I by 1. So I will become 1. I is equal to 1. And exchange AI with AJ. So exchange 1 and 3. So you will get 0 and 6 here. Exchange 1 and 3. So you will get 0 here and 6 here. 0, 5, 6, 2, 4. Now increment j by 1. So j will be equal to 4, I is equal to 1, and x is equal to 4. So 2 is less than 4, condition is true. That is a of j, that is a of 4 is 2. 2 is less than my key 4, condition is true. Now increment I will be equal to 2. Exchange I2 with A2 with A of 4. So exchange these two numbers. 2 with 4. So you will get 0, 2, 6 and 5. So you will get 0, 2, 6 and 5. Now my loop is over because when I increment j is equal to 5, so the condition becomes false and the loop will be stopped, and you will write a of I plus 1 is equal to a of r. We have to exchange a of I plus 1 with a of r. Now how will you do it? You have to exchange a of 3 because I was at 2. So exchange a of 3 with a of 5. So you will get 0, 2, 4, 5 and 6. So this list will become sorted and it will return you I is equal to 3. So this will return you q is equal to 3. The partition has to take place at 3 elements. So towards the left, you are seeing the elements towards the 4 are less than 4 and elements towards the right of 4 are greater than 4 itself. So this is your q is equal to 3 only. Okay. So that means quick sort here partition 1 comma 8 1 comma 8 has given you 6. Now again you are applying quick sort of 1 comma 5 and quick sort of 7 comma 8. So its partition, that is p of 1 comma 5, has returned you 3 because at third position the sorting the pivot element was fixed as 4, and quick sort 1 and 2, and here it was 4 and 5. So this is how recursively it will make the call. Now let's do the recursion, I mean quick sorting to these two numbers, that is quick sort of 7 and 8. So how will we do it? Last case was left quick sort 7 comma 8 index from this list. So that is 8 and 9. 8 and 9. So J will, this is my index number last, that 1 and 2. Okay. So J will move between 1 and 2, and A of R, that is A of 2, which is equal to X. X is equal to A of R, which is equal to A of 2. X is equal to A of R, which is equal to A of 2, that is 9, and I will be 0. Okay. Now you will see 8 is less than 9. Condition is true. Increment I will become 1, and exchange A of I with A of J. So that means your I has become 1. So both are pointing to same position. Both are pointing to I is equal to 1 and J is equal to 1 are pointing to same position. So no swapping will take place. The number 8 will be fixed in this position only. So 8 will remain here only. Okay. Now for J is equal to 2, the loop will become false as we have seen in the algorithm. Now exchange A of I plus 1 with A of R. Fine. So your position is again swapped. That is, your 9 will remain here only. It will not be swapped because A of I plus 1 would be 2. So 9, I was at 1. So I plus 1 would be 2, and this place will remain as it is. So we are not going to swap it. So this will be done here. Okay. So we are finished with this problem. Now, how the complexity analysis is done? First of all, space complexity. See, we have n elements, and if we are choosing the pivot element in such a way that it is dividing the entire array into the two sub arrays, that means it would be divided by 2 only. N will be divided by 2 into 2 equal halves. Then this n by 2 again will be divided into 2 equal halves, n by 4 and n by 4, n by 4 and n by 4. That means the complexity will depend upon the number of levels we have gone through. Complexity will be depending, space complexity will be depending upon the number of levels we have made in order to sort this list. Fine. So that will be equal to O of log n, because whenever we talk in the terms of levels, we always give the complexity in terms of O log n. Fine. Or we can now calculate the time complexity. This is space complexity. N divided by 2, n divided by 2. Then you will get n by 4 to equal halves of this list. So this will be equal to O log n. Now time complexity, we will do that. The short will be equal to so this will be roughly equal to, this is equal to Tn. Tn is the time which is taken by quicksort to sort n elements. Here the partition will also be performed on the n elements. So definitely the time would be O of n or some constant. And this will be Tn by 2 since we are partitioning list. Either the halves are equal or they are not equal, but still we are dividing the list into 2 equal halves. So this will take this much of time. So roughly we can say this equation will be equal to Tn is equal to n plus or any constant plus 2 Tn by 2. Okay, 2 Tn by 2. If, or you can say, sorry, here coefficient of A is 2 and B is also 2 and Fn is n and D power is 1, and applying the master theorem, by master theorem, which we have done in the previous lecture, condition 2 satisfy, where A is equal to B. So it is equal to, n log n. So it implies big O of n log n. Okay, because when you are partitioning, it is log n and the n elements are divided. So this becomes n log n. Fine. Now this is your best case complexity when they are divided into 2 equal halves. Okay. But when they are not divided equally, then what happens? Suppose the list is worst case we are discussing. Suppose the list is already sorted. 1, 2, 3, 4, 5, and 6. Supposingly here we are choosing first element as the pivot element. We are choosing first element as pivot element. That means your n will be divided into 1, n minus 1. Your starting index would be 1, n would be the pivot element which is already sorted. and here you will get n minus 1 elements. Now second element will be fixed and you will get n minus 2 elements. Now third elements would be fixed and you will get n minus 3 elements. Then fourth element would be fixed and you will get n minus 4 elements. Fine. So that means if we sum up all this will become O of n square. That means your best case complexity is n log n and worst case complexity is O of n square. Big O of n square. You may write it big omega because big omega is, I mean, best case complexity. So it is big omega of n log n, and here it is O of n square, or we can also write it as O of n log n. There is no problem. And O of n square is your worst case complexity for this. Now, I told you that, so this is sometimes the problem because the complexity has increased multiple folds. In this the case, since log n is a very small figure, so n square is a very big figure, means our complexity increases too much, complexity is too large. So this is a problem with the quicksort. You can improve the case by using one thing. Here two suggestions are there, that you can improve the time complexity or you can bring down the time complexity to n log n. First is to choose middle element as pivot element. Second, you may choose any random element as pivot element. When I started the lecture, I told you generally it is advised or people do like to choose middle element as pivot element. Why? Because when the list is divided into two equal halves, it gives us the time complexity of n log n. It generally gives us the time complexity of n log n. But whenever you choose first element or last element, there is a probability that they may lie somewhere in between. Okay, and it could be uneven partition of, it may result in uneven partition of list. So the complexity definitely will increase. It may be big O of n square. And if you choose any random element as a pivot element, means somewhere in between you are choosing any element as a random element as pivot element, it is likely that random element could be the middle element, or so that it may result in the complexity of n log n to big O of n square. Because if you choose the middle element, then the complexity would definitely be n log n. And if you choose somewhere after the middle element, it could vary from n log n to O(n) square. So generally, it is recommended to choose the middle element as the best is to choose the middle element as the pivot element. Okay, thank you so much for this lecture. And if you have any problems or any questions you want to get solved, if you are not able to solve it, share your screen with me or put your queries in the WhatsApp so that I can solve it and revert it back to you. Now it's the poll time. So let's do the poll questions. Give the answer to the above said poll questions, please. 38 people are there, only 34 have participated. What about rest of others? Hurry up, give the answer, otherwise I'm going to close this poll. So why quicksort is the fastest one? Answer is right, quicksort is fastest. Why? Can somebody tell me why it is the fastest one? Please let me know.